Hello, scholars. So today we're going to take a look at Chapter 3, Big Idea Number 1, Graphing Quadratic Functions. And so when looking at our learning targets, we have I am learning to graph quadratic functions, and I am learning to find and interpret the maximum and minimum values of a quadratic function. Some big things that you need to realize is in a quadratic function, the greatest exponent is 2. These functions can have a quadratic term, a linear term, and a constant term. So A, B, and C. Big thing here is A can never, ever, ever equal 0. And the graph of a quadratic function is that parabola. So that smiley face or the frowny face. So let's take a look at an example by making a table of values. So it says graph f of x equals 3x squared minus 12x plus 6 by making a table of values. So we have our basic values first, 0, 1, 2, 3, and 4. So substituting in 0, we have 3 times 0 squared minus 12 times 0 plus 6. So the zeros cancel and I get 6. So my first point is 0, 6. So I'm going to go ahead and I'm going to put 0, 6 on my graph. All right, so then we have 3 times 1 squared minus 12 times 1 plus 6. So we have 3 minus 12, which is negative 9, plus 6, which is negative 3. So now we have 1, negative 3. So I'm going to go to 1, and then negative 3 is right around here. Now to 2, 3 times 2 squared minus 12 times 2 plus 6. 2 squared is 4. 3 times 4 is 12. 12 minus 24 is negative 12. Plus 6 is negative 6. So I have 2, negative 6. 2, negative 6. All right. Then we go on 3 times 3 squared minus 12 times 3 plus 6. This is all calculator work right now. So we get negative 3. So we have 3, negative 3. So 3 goes to negative 3. And then we have 4. 3 times 4 squared minus 12 times 4 plus 6 gets us 6. So now we have 4, 6. All right, so I've plotted all of my points, and it does start to outline that U shape. So go ahead and let's take an opportunity to draw that U shape. All right, so we have that nice U shape. And notice, in this example, there seems to be a pattern. We look at these f of x values, we go 6, negative 3, negative 6, negative 3, 6. So yeah, it did pattern. And this is due to what we call the axis of symmetry, which in this case is at 2, negative 6. The axis of symmetry is this invisible line that cuts our parabola directly in half to where those both sides, when folded in, will fold onto each other. So that is our axis of symmetry. And in this case, our axis of symmetry is an equation x equals 2. All right, so that axis of symmetry is that line graph of a parabola that divides the graph into two congruent halves. Each side of the parabola is that reflection of the other side. The axis of symmetry will intersect the parabola at one point called the vertex, right here. So this is our vertex. The vertex is always going to have the same x value as our axis of symmetry. So in this case, our axis of symmetry said x equals 2. So we go 2. And what was our y value? Negative 6. So that is our vertex. All right, some key things that we want to recognize here is that the axis of symmetry, if given just the equation, is equivalent to x equals negative b over 2a. The coordinate for the vertex is x equals negative b over 2a. The y value is f of negative b over 2a. And then the y-intercept is always that c. So using that information, let's go ahead and graph the following quadratic function. First, I want you to find the axis of symmetry, then find the vertex, then plot the y-intercept and its reflection, and connect the points with a smooth curve. So what I really like to do every single time I have a quadratic, I like to label my A, what my B is, and what my C is. So remember, it is AX squared plus BX plus C. So in this case, the A is 1 because there's an invisible 1 in front of this x squared. The B is 4, and the C is negative 3. All right, so the first says, find the axis of symmetry. Axis of symmetry is an equation that says x equals negative b over 2 times a. So what is negative b? Well, negative b is negative 4 over 2 times a, which is 1. So I have negative 4 over 2, which is negative 2. So now I know my axis of symmetry is x equals negative 2. So I'm going to have that invisible dashed line. It's just for a point of reference at negative 2. All right, so now we have to find the vertex. The vertex is a point x, y. Well, we know x is already negative 2. To find y, we do f of negative 2. So we have negative 2 squared plus 4 times negative 2 minus 3. So 4 minus 8 minus 3. And we get the value of negative 7. So now we know that our vertex is the point negative 2, negative 7. So let's go ahead and scroll down so we can see. So our vertex is at negative 2, negative 7. So right here's our vertex. Our y-intercept is whatever c is. C is 3, so our y-intercept is 0, negative 3. So we go to negative 3. Now, because of this axis of symmetry, whatever point I place on the right-hand side, I can also place on the left-hand side. So now we have negative 4, negative 3 as that axis of symmetry, because of that axis of symmetry. And then we're going to connect the points with a smooth curve. All right, so now we have that smooth curve, and there is our parabola. That one is done. All right, so now one thing that we also need to recognize is the y-coordinate of that vertex is actually the maximum or minimum of our entire function, because it's either the highest point or it's the lowest point. All right, so key concept here. If a is greater than 0, your function has a minimum. If a is less than 0, your function has a maximum. So let's take a look at this next example. A equals negative 4, B equals 12, and C equals 18. So determine whether the function has a maximum or minimum. So in this case, for part A, we have negative 4 is less than 0. So therefore, we have a maximum. So now we need to state the maximum, which means we have to find our vertex. Well, vertex form, or the vertex says you find the value negative b over 2a. And place it in the function to get that y value. So first, find negative b over 2a. In this case, it's negative 12 over 2 times negative 4. So we get 12 over 8, which is the same as 3 halves. So step 2, do f of 3 halves. So negative 4 times 3 halves squared plus 12 times 3 halves plus 18. Now, if you did not use 3 halves and instead use 1.5, that is absolutely all right. I just prefer fractions personally. So I'm going to continue with fractions. I might flip-flop back and forth, but just know that you can use decimals if you choose to do so. So simplifying this out, and I just put it in my handy dandy calculator, I get 27. So my vertex is 3 halves, or 1.5 comma 27, which means our maximum is at 27. All right, now we have to name our domain. Were there any restrictions on our f function? No, it's a quadratic, it's a parabola, so there are no restrictions on our f, so we have all real numbers, which is negative infinity to infinity. However, with our range, we had a maximum. We had a highest value in which y could actually be. So, because we had no minimum value, it goes from negative infinity all the way up to our maximum at 27. Because we can touch the value 27, it is included in that range value. So we put a bracket over it. All right, so we have talked about graphing quadratics. We used a table. We looked at that vertex. We looked at the axis of symmetry, the max and min, the domain and range, and even that y-intercept. So if you have any questions, please do not hesitate to email me or ask me in class, and I hope you have a wonderful day.